Hello everyone, this is going to be Leetcode problem number 861, score after flipping matrix. So we can start with the definition. We have a two-dimensional matrix, every value is 0, 1 in that matrix, and a move consists of choosing any row or column and toggling each value such that we change all zeros to ones and all ones to zeros. So basically just flipping each row or column. And then after making any number of moves, every row of this matrix is interpreted as a binary number, and the score of the matrix is the sum of these numbers. Return the highest possible score. So we can go to the example given. This matrix right here, the highest possible score is here is 39. This was the example on the web page, and the question is how do we get to this in a way that is sort of intuitive and quick. So one note, immediate note that we have about binary numbers, and any number actually in any base, is that a digit in a more significant position is going to be greater than any number that does not have a digit in that position, right? 1, 0, 0, 0, if this is 2 to the 0, 2 to the first, second, third, and fourth, right? This is 16, right? 2 to the fourth is 16. And this number is going to be 15. 15 is greater than 16, and regardless of the contents of the right positions, it does not outweigh the single left position. So maybe we can start by optimizing rows, right? Because if we optimize rows, we actually can change it such that the most significant bit is all ones, right? If we change this row, because it has a 0, we can get this row, and then don't change the other two rows, and we preserve the most significant bits. So from here, the question is can I just change the columns now and be done? And maybe immediately it's not so obvious, because maybe if you change a column, let's say we change this column, maybe the score would decrease, and maybe it would be like less optimal than what we started with. So the first question, I guess, is when do we change the column? Well, if this is the 2 to the 0 and 2 to the 1, 2 to the second, and 2 to the third, each column is another sum, right? This position of this column in all of these binary numbers, 2 to the first is contributing 2 to that sum, and 2 to the third is contributing 24, because we have 3 8s in base 10. And so we want to flip a column if the ones are less than the number of zeros, right? So we do that, and we actually so we'll flip this column, and we're left with this as our final matrix with the score of 39, which in the problem said was the correct answer. So why does this algorithm work is the real question. And I guess it stems from how we think about rows and columns, and whether or not columns are dependent on rows, and whether or not rows are dependent on columns when it comes to optimizing the sum. So in reality, each row is independent from each other row, right? If you flip the top row, that has absolutely no effect on the second row at all. And if you flip the first column, that has absolutely no effect on the second column. It is true that if you flip the first row, it affects all the columns, and if you flip the first column, it affects all the rows, but that doesn't actually matter, because if we just flip the let's say we flip the first row, right, and we'll get 1 0 0 0 and 1 0 1 1, right? if now we want to flip columns, let's say we were done with rows, we can't optimize rows anymore. Let's say we flip columns and we want to flip that column because it has less zeros than ones, and so that would be 1 1 0 0 and 1 1 1 1. Flipping this column, can we imagine that the score would decrease, right? Because that's really all we care about, is whether or not after we make a flip, if the score decreases or not, right? It is true that we could make a row less optimized, as seen here. When we flip this column, sorry, this is actually not correct, 0 1. When we flip, so that would probably make more sense, right? 8 plus 1 is 9. When we flip these two columns right here and here in the previous step, we are basically optimizing the sum for that column, and sorry, we flip this column and this column. We're optimizing the sums for those columns, and therefore those binary numbers may be decreased. For example, this one is decreased. 1 0 1 0 goes to 1 0 0 1, right? But the overall score increased because we made sure that we were increasing the digits for two of the numbers, right? Because we only swapped it if the zeros were less than the ones. So even though we lost some score here, we made up for it by increasing the sums of the other two binary numbers. So that's a pretty straightforward algorithm, I think, and a decent enough word proof. It's probably not, rigorous or anything, but intuitively, I think it makes sense. And this problem was pretty decent and a good example, like I said, of just trying an algorithm, seeing if it works, and if it does, trying to think of why it works or why it doesn't work. And so thank you for watching, and as always, good luck on your interviews. Trust yourself. Don't try to cram, and I'm sure you'll do great. Thanks.